So we're going to wrap up our unit of these quadratic functions with actually introducing a new function. This is a polynomial function. And yeah, it's a cool looking graph, man. You want to be the kind of math person that does those graphs. It's awesome. Because it's really curvy and things like that. It's not straight, it's not parabola. So we have a curved graph here. That's pretty cool. It's a polynomial graph. So you've seen polynomials before, like x squared and maybe x to the thirds or x to the fourths or things like that. So these are pretty neat little functions here. So let's take a look and talk about it a little bit. So we're going to call that graph that you see in your paper function f. And we want to know what its zeros are. Well, you know what the zeros are. The zeros are where the graph crosses the x-axis. So let's see, did you get your zeros to be, let's see, one of them is right here at -2. One of them's here at +1. The other one's here at +2. So then its zeros are x equals -2, x equals 1, and x equals 2. So then an equation that could model this in its factored form. So we got to remember the factored form for a second. So the factored form is when we write it out as factors. So we got to think for a minute. If one of our zeros is x equals -2, then the factor that comes from it is x plus 2. And the reason why that works, I'm going to go to this right side here and work on that for a second. If x equals -2, remember we wanted our factors to equal 0. So if I add 2 to both sides, I get a 0 on the right. So my factor here is x plus 2. So we're kind of working backwards from our factoring. And if I write it like this, you might remember, oh, when you see a pair of factors like x plus 2, it means that the root or the 0 is x equals -2. So the same thing here. This time we get x minus 1, because a factor of x minus 1 will give a 0 of x equals 1. And our third one is x minus 2. So that's a possible equation of it. I say possible because there's other things that we can do to it. We can put like a 2 in front of the parentheses there. We can do like a 2 out there. Or we can put like a -2 out there. Or we can add 3 to the end of it. But in general, the equation in its factored form is going to look just like we see here. So that's one of the things you want to be able to do, is to write an equation in its factored form. 3 factors. So what kind of a polynomial is that? It's not a parabola or a quadratic. No, so let's just take a minute and identify some of these different functions that we do. And yes, you've seen a constant function before, a horizontal. That's a degree 0. That's like y equals 3, something like that. You've seen linear functions in the middle, quadratic functions on the top right. The 2 new ones are on the bottom. A 3rd degree polynomial, something that looks like y equals x cubed. That's our cubic function. Notice that in the cubic function, when x is negative, the graph is in the negative area. And then it goes up above the axis. And as x gets bigger and bigger and bigger, then the y value gets bigger. So this graph goes on forever into quadrant 1, into the top right of the graph. Compare that to our quartic function, where you have like a y equals x to the 4th. Those graphs make like a W shaped. So if you go from left to right, the graph starts off being positive, crosses the graph, comes back up, goes back down, goes back up. So it has 4 zeros. A quartic function has 4 zeros. A cubic function has 3 zeros. A quadratic has 2. So a linear really has 1 0. And a constant function does not have a 0. So some interesting things there. Did you copy that down on your paper? Alrighty. So this graph of f looks kind of similar. You might remember the one from before, the picture that we opened our lesson with. So the only difference here is that we have that negative there. What's that negative doing to the graph? Well, do you remember from your transformations earlier of y equals x squared that a negative flips the graph over? So that's what it's going to do. A negative is going to flip the graph. So if you remember what our graph of f of x looked like, the original graph, the one that you started with in your paper, I'm just going to draw it real quick. it had a 0 of, let's see, it came up this way. It went through -2, then 1, then 2. It looks something like that. So then this graph here is going to be the same zeros, but this time it's going to be reflected over the x-axis. It's going to be flipped over. So it's going to come down this way, turn around, then go up, and then come back down that way. Hey, you know what? If you're ever unsure about this too, pull out your graphing calculator, type the graph in, press graph, and see what it looks like. At least you'll be able to see what the zeros do. So what does a negative do in front of it? It's going to flip our graph over. Exciting stuff. But wait, there's more. So take a look at this function for a minute. It's the function x times the square of x plus 3. Interesting. I'm going to take a minute. I'm going to rewrite that for a minute. Because the square of x plus 3 means I have 2 x plus 3s. That's what our function looks like. So then our zeros of the graph, remember the zeros are when each factor equals 0. So one of them is at x equals 0. One of them is at x equals -3. And the other one is at the same value, x equals -3. So notice that x equals -3 occurs twice. So how does that affect our graph? What that's actually going to do is it's going to create what I call a bounce on the graph. And what you might remember in your transformations was that the x plus 3 squared, like if we graphed this one, what you might remember is that it moved over to the left 3, so that graph looked like that. There's my bounce. Right here is where my graph is bouncing off the x-axis. It goes down, touches it, and boing, goes back up. So then what will this graph look like? Well, let me show you. I don't want to confuse anybody with all those different graphs there. So let's see, we have one of our zeros at 0. We have another one at -3. Now it's an x cubed graph because there's 3 x's. So let me go back a little bit. X cubed graphs look like this down here on the bottom right, or on the bottom left. This is what this x cubed graph looks like, this cubic function. So notice it starts off low, and then it goes up high. So what's this graph going to do? It's going to start off low. It's coming up to x equals -3, and it bounces, boing. At some point, this graph is going to turn around and go through there and then go up forever. And if you notice, I'm not really labeling my y-axes here, because my y-axes I don't really care about, to be honest with you. I just want to know where the zeros are. Later on in other math classes, you can find out y values too. But right now, this is good. So check that out. Notice the bounce was used. Notice the fact that it's a cubic equation, so it has this cubic graph shape. Things to be aware of. Let's keep going. Now that we know that there's like a little bit of a bounce occurring or things like that, let's sketch these graphs. So we take a look at our first one. F of x equals x plus 3 times x squared minus 4. Oh, wait. Look on the right side. There's a hint. What's the hint? Oh, yeah. Let's factor x squared minus 4. Because x squared minus 4, it's perfect squares. It goes to x minus 2 times x plus 2. And now I'll bring down my x plus 3. So let's think about what this graph is going to look like then. The zeros of it are going to be at x equals -3, x equals -2, and x equals +2. It's a cubic function. There's 3 different zeros for it. There's 3 roots for it. So when I draw my graph, I got zeros at -3 and -2 and +2. It's a cubic graph, so it starts off in the bottom left of the graph. It goes up through -3, down through -2, up through +2. There's a quick sketch of my graph f of x. I wouldn't ask you to graph this on graph paper. You're going to make a sketch of it. So check out our next one. F of x equals -x. Oh, -x. Yeah, that negative is going to flip the graph over. So I got to remember that there's going to be a flip going on in this graph. And I got another hint. I think I know what my hint's going to say. I can't drag in blue. Got to put the pen down. What's my hint? I got to do some factoring. Yeah. So let's factor that x squared minus 4x plus 3. So let's say I get negative x times x plus 2. My two factors then. I need numbers that are going to multiply to 3 and combine to negative 4. How about a negative 3 and a negative 1? So now my zeros, oh, got a negative in there. My zeros are going to be x equals 0, x equals negative 2, x equals 1, and x equals 3. All right, a lot of stuff going on in this graph. Holy cow. So let's see, we got a 1 at 0, we got a negative 2, a positive 3, a positive 1. Let me make those 4 dots there. So now, this is a quartic graph. There's 4 x's. So it's going to look like this one on the bottom right. It's going to look like a W of some sort. But it gets even better because that negative flips the graph over. So it's going to not look like a W, it might look like an M. M for Mahoney, no M for math. It's going to look something like that. That's what our graph is going to look like. Cool. M for, is there any more we can do? Oh, yes, there is, my young, eager student. Yes, indeed. We're almost done, though. So let's say we have a function whose 3 zeros. Oh, good, I know there's 3 zeros, because that tells me that it's going to be an x to the third graph. It's going to look something like that. So let's see. The zeros are at negative 2, 1, and 4. Zeros are at negative 2, 1, and 4. See if you can sketch that graph. Let's see, we're going up through negative 2, down through 1, back up through 4. There's our sketch of our graph. Do you know what its equation is going to be? Do you know what it's going to look like in terms of f of x? So if the 0 is at negative 2, the factor is at x plus 2. If a 0 is at 1, the factor is at x minus 1. If the 0 is at 4, the factor is x minus 4. An equation like that is good. Alrighty, one last one here. How about a function whose 4 zeros? That's going to be an x to the fourth graph. Ooh, and 2 occur at 3. What do you think is going to happen there? Boing! See if you can make a sketch. I got a negative 4, I got one at negative 1, and I got 2 of them at 3. So let's see, I don't know if there's a flip or not going on, so I'm going to assume that there's no flip. So I'm going to come down through negative 4, up through 1, and then boing, I bounce off at 3. Pretty neat. Do you know what the equation is in factored form? So let's see, we got f of x equals. How about we start with an x plus 4 because the 0 is at negative 4. We have an x plus 1 because the 0 is at negative 1. And check this out. You can write, if you want, 2 x minus 3's. But we know since 2 of them are occurring that it's going to be the square of x minus 3. So right now you should be able to make a graph, identify the zeros of a graph, and actually write the factored form of the equation based on the information that you're given.